So this is a list of functions you must know for any calculus course. And of course, as we are going to be embarking on Calculus 1, it is necessary for you to know almost actually all of these functions. So we're going to go through all of these in double quick time, listing basically the basic concepts, maybe spending 5 to 10 minutes on each in separate videos. So this one will be on polynomial functions, the next on polynomial functions. The next one's rational functions. These are the fractional functions. Exponential functions and EX. We'll spend a little bit of time on those, quite important. The logarithmic functions, so we'll revise the laws of logs, and of course we look at the most important one, which is the natural log, or ln x, as a lot of students like to call it. Then we look at the trigonometric functions, and finally hyperbolic functions. Now hyperbolic functions is different schools have different universities have different syllabi. Sometimes hyperbolic functions taught part of Calculus 1, and sometimes it's taught separately it's taught in Calculus 2. So anyway, we will begin first with polynomial functions. So let's get on with it. Polynomial functions. Polynomial functions should be all very familiar with at this stage. So f of x is, a polynomial function usually is a0 plus a1x plus a2x squared plus a3x cubed plus plus anxn. Okay, so now since this is a quick revision, this is called an nth order polynomial. Okay, nth order polynomial. A polynomial simply is something that has lots and lots of powers of x. Okay, it can have lots of them, or it can have very few of them. Okay, the simplest polynomial function is the constant function, like f of x equals some number 1, okay, or f of x equals 2. Okay, this is also a polynomial function. It's constant. Here's another example. F of x equals 1 plus x, known as the linear function. G of x equals 1 plus x squared, quadratic function. So this is the linear function. Okay, this is the quadratic, well known quadratic function. Okay, or quadratic polynomial, which means it's a second order polynomial. Okay, it's called a quadratic. Then we have h of x, which is a cubic. For instance, 1 plus 2x plus 3x squared plus 4x cubed, for the sake of argument. Okay, this is a cubic poly. So I'm going to use the word poly here, okay? Polynomial. So linear poly, quadratic poly, cubic polynomial, and so on and so forth. The alternate notation, remember, y equals x5 plus 3x4 minus 2x cubed plus 3x squared minus 5x plus 7. So traditionally the highest power is first, so x to the 5, then x to the 4, then x cubed, and so on and so forth. So for instance, the quadratic that I have up there, it's more likely that it's written in this form, which is like 2x squared minus 5x plus 3, for instance, and so on and so forth. So the highest power usually comes first. Okay. Now, another thing to understand is in any nth order or any polynomial, these numbers here, okay, these are called coefficients. Okay, they're called coefficients of the polynomial. Okay, these are called coefficients of the polynomial. All of these guys here, this one, and so on and so forth. Okay, all of these are called coefficients. So just if we go back to our examples, here the coefficient is 1, here the coefficient is 3, this is minus 2, this is 3, this is minus 5, and this is 7. Here it's 2, minus 5, and 3. These are all coefficients of polynomials. Right, remember, basics, very simple. Anything in a straight line, as in one row, no fractions, it's just a number multiplying a power of x. That's a polynomial function. Okay. Okay, one other thing you need to know is the domain of all polynomial functions are all reals. Okay, the domain of all polynomial functions is the real number line, minus infinity to plus infinity. Polynomial functions can take on any input from minus infinity to plus infinity. So any input can be fed to it. It is much more difficult to say what is the codomain or the range of a function. Range of a polynomial function can change from positive only to negative only to all reals as well, or other restricted restricted ranges of values. So we cannot make a generalization of this, but we can say that the domain of all polynomial functions is all real numbers. So the next one we're looking at is our rational functions in the list of functions, rational functions. So a rational function can be thought of as a function which is made up of one polynomial p of x divided by another polynomial q of x. So here where we're saying that p of x and q of x are both polynomials. Okay, so this p of x over q of x, basically to understand it, rational functions as rational numbers are what? Are fractional functions. Functions that can be expressed in form of a fraction. Examples. Let's look at some very quick examples. G of x equals x squared plus 3x minus 2 divided by x squared minus 4 for the sake of argument. Okay, this is a rational function. Now, things that you need to be aware of with regards to the rational function. The domain of all rational functions isn't necessarily always all real numbers. We note a problem in rational functions. Whenever we encounter a fraction, we may encounter the situation where some number could be divided by 0. So 1 over 0. Okay, 1 over 0 goes to infinity. Now, we will talk about infinity a little bit later on. This is quite important when it comes to rational functions. You see this denominator here? This denominator is going to, for x equals plus or minus 2, this denominator is going to become 0. Because if I put 2 in there, I get 4 minus 4, 0. If I put minus 2 in there, I get 4 minus 4, 0. So the domain of this particular rational function would be, we could say that it's, for instance, we could say x belongs to all real numbers except for x belongs to all reals such that x is not equal to plus or minus 2. So this is how we would define the domain of this rational function. Okay, so that's all I want to say about rational functions for the time being, just to get you to understand whenever we mention rational functions, that's what we're talking about. Don't worry about the 1 over 0 equals infinity. If you've never seen that before, you don't get it. When we come to the concept of limits, the first topic in calculus, we'll discuss infinity in depth. Okay, so for now, we'll stop here with regards to rational functions. The main thing to keep in mind is the domain of a rational function. You need to look at this qx polynomial, and you have to find if there are any x which make it 0. Now, by the way, don't take it for granted that it's always going to be 0. I'm going to show you a quick example here. Some h of x is equal to x over x squared plus 1. This has in fact the domain, okay, is in fact all reals. Okay, why? Because x squared plus 1 is never going to be 0 for a real value of x. For certainly an imaginary value or complex number, yes, but it will not be for a real value. Okay, I think that's enough for rational functions. Let's move on to the next topic.